My name is Mike Lanahan, and I'm the head of business development and commercialization at Agrovita. It goes way back because as long as I could remember, I was interested in science and nature in particular. And it was probably about fifth grade, I spent the first money I'd ever earned on two great big books that I'd seen in a bookstore for a long time. One was on science and one was on nature. And so I spent a lot of money as a kid on those two books, and I still remember reading those books very vividly today and learning a lot about science and nature. And then it was probably in about ninth grade, I remember very distinctively a Time magazine article coming out, and it was a cover story in Time magazine. And the article was about genetic engineering, because right about that time, Cohen and Boyer did the first molecular cloning. And so the whole article was about the sort of future of genetics and molecular genetics. And at that point, I kind of knew that's what I wanted to do. If you look at agriculture generally, I mean, the last 10,000 years, humans have domesticated different agricultural species like corn and rice, and they've bred those to be much more productive. And what the technology today is allowing us to do is to change the composition of that grain. It changes what the grain produces. So producing enzymes for animal nutrition and grain processing really is just the tip of the iceberg. Of course, so Agrovita is very interested in getting into the development of functional proteins that can affect the health of the animal. And that's either by working on the animal directly to improve the animal's health, or indirectly by affecting the interaction of certain pathogenic organisms with that animal. So delivering functional proteins to animal health is one of the really big areas that I see on the future, because a lot of these active proteins would be needed in sufficient quantity to deliver their beneficial effect. And plants give you that capability. But the really big application, I think, for humans long-term is that we're going to be able to get away from a focus on agriculture just being a means of production to really changing the output of what the crops produce. And as the human population grows, there's a higher and increasing demand on protein that goes into our diets. So one of the things that we can do with today's technology is we can change the type of proteins that plants produce for human nutrition. And that's important really for two reasons. The first reason is that the potential to continue to produce animals on this planet is going to be limited as the population grows, and the environmental resources that are required to produce all that protein is going to become significantly taxed. So if we can direct a higher proportion of the direct output of plants into producing nutritious protein for human diets, that's going to be a great thing. And the second is going to be to change the function of those molecules. So there's a lot of proteins today that have particular function in food systems, and that functionality is important for the taste, texture, and the performance of different food products. So besides specific impacts on nutrition, this whole area of food functionality can be positively impacted by the type of proteins that we can produce in plants. So that's, I think, the really big potential for ag biotech in the future is to really address directly the human needs for nutrition, and not just indirectly by producing more crops. So for animal nutrition and food ingredients, it's really working with our potential customers to understand what their needs are and where the opportunities might be. So the next steps for Agrovita really, I think, as we look at these opportunities beyond animal nutrition and starting to look at human nutrition, is what are the functional proteins that we would like to try to emulate with proteins that are produced in plants. So when you look at specific food ingredient sectors like dairy or beverages, we need to understand what some of the unmet needs are for the products that consumer products goods companies are making, so we can understand what type of ingredients they're going to require. So whether it's meat substitutes or functional proteins for you name it, any number of applications. The proteins that are used today that are derived from animals bring a certain functionality into that application. So they're not serving just as protein that's going to be digested and used nutritionally by humans, but they're proteins that deliver specific functionality to those foods. And I think that one of the market opportunities is to begin to use plants to replace some of the proteins and develop products that deliver functional aspects into the foods that consumers want. From our perspective in Agrovita, we would look pretty carefully at what the requirements of that product would be. So could it be used directly as a primary product from agriculture? That is, if we produce a protein in corn like we do for animal nutrition, that corn grain itself can just be ground and incorporated directly into the animal feed to deliver the functional benefit of that protein or enzyme. In the case of a food ingredient, we need to look carefully at what the taste, purity profiles, the texture, the color are for a specific application. So if we wanted to replace specific animal proteins that have the functionality of egg white proteins, we'd need to look at all the characteristics, not only the function of the protein, but what would our product have to look like if we were to recover it from a plant source and develop an ingredient? How pure would it have to be? What would it have to look like? Would it deliver any taste attributes at all, or should it be neutral? So we would consider all those things when we envisioned a product that is a way to replace that product and manufacture it. So we would look at things like, well, what's the appropriate plant host? Would we want to produce this product in corn? Could we extract it from corn? Is it something we'd want to make in soybean? How would we extract it from soybean? Or even look at something like rice. Since it is a long process, you've got that in the back of your mind already, and you know that it's going to take quite a bit of staying power and perseverance to make it happen. But what's interesting is each little step along the way is a measurable indication of success. And I would say that those successes come along at a rate of, every other month or so, or every 3 months. So that's enough motivation to keep the team going. With my team in the past, we used to celebrate all these small successes. So I'd put together a series of objectives for the whole team. And I'd have these big team objectives. But every time we hit a little milestone in a project, we would have a celebration. And the celebration was usually something simple, like a bottle of champagne and some strawberries. And it would happen, the day that the result came in. And I think that celebrating those little steps along the way are an important way to keep everyone engaged in the success of the team and pushing the project forward. So in a project that might take 6 or 7 years to commercialize something, there's a lot of interesting wins and milestones along the way that can keep a team together and motivated.